IBC Media has a long-standing legacy of managing partnerships and establishing grassroots efforts in the blockchain space, essentially in the Indian market. After successfully kicking off its debut event in 2018, IBC Media is geared for its second edition, IBC 2.0, with the theme Continuum. The main conference will be held um, later during the year and will be a convergence of the best in blockchain and Web3, including thought leaders, speakers, accelerators, policymakers, VCs, and students. Polkadot is our headline sponsor, and we have onboarded top line sponsors, accelerators, mentors, and jurors for the massive events lined up. In today's session, we will be learning about Polkadot, a heterogeneous multi-chain that connects and secures blockchains with a pool security and interoperability. Polkadot is built to connect private and consortium chains, public and permissionless networks, oracles, and future technologies that are yet to be created. The workshop also features a hands-on activity that introduces Substrate blockchain building framework, which is used to develop Polkadot and its parachains. Now, if you are a little too confused about the terms I just used, don't worry, it will all make sense by the end of this session as we have Mr. Radhakrishna Dasari with us today. Hello. Um, hello, Radhakrishna.
Hey, can you hear me?
Hi. Yes, I can hear you.
Okay.
So we have Radhakrishna here with us today. He is a technical educator at the Web3 Foundation, which nurtures technologies and applications in the fields of decentralized web software protocols. Prior to joining, he was a faculty at Department of Computer Science at University of Vermont and has an MS and PhD in computer science from the University at Buffalo. The State University of New York, Radhakrishnan is excited to pull his skills to use for educating professionals and the general public about the vision of Web3 and its technology stack. So let's dive right in. Over to you now, Radhakrishna.
Sure. Can you see my screen?
Yes, we can.
Perfect. So we can get started. Yeah. So I'm Radhakrishna Dasari. I'm like a technical educator, like Dhruv just mentioned, at Web3 Foundation. So Web3 Foundation is based in Switzerland. So we are one of the core organizations that push forward, like Polkadot and its ecosystem in general. Anyway, so let's dive into what Polkadot is and what all of these terms right there mean, right? So the parachains and substrate and so on and so forth. So we'll try to keep this like interactive. So I'm happy to, so you can post your questions in the chat. I already shared the presentation as well. So, feel free to click on those links and then ask questions if you have them in the chat. All right. So to begin with, like if you looked at Polkadot, if you just search for Polkadot, you would see this image popping up. So this is our key design logo. So here, basically every single dot you see there is actually a blockchain, meaning, so Polkadot is a network of blockchains. So a formal definition, a technical definition of that would be Polkadot is a heterogeneous multi-chain, meaning every single blockchain that you see here has its own logic. So the state transition logic of all these blockchains is unique and it belongs to whichever organization is sort of hosting that one. And yeah, so that's the meaning of heterogeneous here. So this is a little different than like Ethereum 2.0 if you're following that space. In Ethereum 2.0, the shards or these blockchains that they are all homogeneous. So they're all sort of defined by the same state transition logic of the Ethereum main chain. Anyway, so Polkadot is like a heterogeneous multi-chain that connects and secures blockchains with pool security and interoperability. So these blockchains, which run on top of Polkadot, so they are actually secured by Polkadot, and they can also talk to each other through the Polkadot network. Yeah, so I want to reiterate this statement again. So Polkadot can provide security for sequential parachain blocks in parallel. So you have a bunch of blockchains that are running, which as they run in parallel, we call them parachains. Blockchains that are running in parallel on Polkadot are parachains. So these are, parachains are actually producing blocks, and these blocks are secured by Polkadot in parallel. So as we go further, all of this sort of makes sense. Like, why do we need, a network like Polkadot to you have all these parachains on top of it, and why do they need to be secured, and why do they have to talk to each other? So this is right from the workshop description that we have. The point being, right now, if you go to CoinMarketCap or any sort of website, if you just see the total number of tokens or blockchains that are out there, there are plenty. So clearly, there's a lot of interest in general about like using blockchain technology for different use cases by different organizations. So the point being, so Polkadot in general, the parachains, they can be like private networks. So they could be public networks or, some kind of hybrid, like consortium chains. So it's wide open. So anybody can build, if they feel like blockchain technology is going to solve their problems. So they can deploy a blockchain on top of like Polkadot. And the interesting thing about Polkadot is that it's not, as you'll see, Polkadot network by design has the upgradability feature, meaning it's not like, so Bitcoin, as you can see, over the past like 10 years, the number of upgrades that happened on Bitcoin are very, very less. Point being, like, there's a lot of complexity in upgrading like blockchain networks. So Polkadot actually sort of solves that particular problem. I'm going to talk about it, in this workshop session as well. But yeah, so point being, let's say in the future, someone comes up with a brand new technology or an innovation that's going to help like blockchain technology overall. So Polkadot has the capability to upgrade itself, seamlessly. So summarizing like what I mentioned so far in terms of like Polkadot architecture. So we're gonna call like Polkadot as a relay chain. So a relay chain that relays messages across like these parachains. So that's where the term relay chain is coming from. So relay chain is a layer 0 blockchain. So everything you hear about, like, Ethereum, Bitcoin, all of these are like layer 1 blockchains, meaning, so they are up here. So typically a parachain in Polkadot, it can have the functionality of the Bitcoin network. It can have the functionality of an Ethereum network, or, so these parachains are very versatile in terms of like what kind of logic they can host. Yeah, so relay chain is the connector. So it's the one that's connecting all these parallel blockchains that are running on top of it. So I gave you the presentation. So if you want to click on this link and then switch to like Polkadot network, you would see an interface like this one. I mean, there are plenty of other, interfaces that sort of show the activities in Polkadot network as well. But Polkadot.js is something most of the developers use. So here you can clearly see that, every block of Polkadot is being produced like in 6 seconds. So right now this number is a bit more, probably it's around 11 or 12 million blocks. Yeah, so you'd see the block hash and the validator who's producing that block, and the events that are sort of recorded in that particular block. So it's a live chain. You can see a lot of like parachain related, events and transactions in there as well. And yeah, so and then it's got like plenty of functionalities which can be, you can have a sneak peek through just like exploring Polkadot.js interface. In terms of like the network itself, so one thing for those of you who are really new to like Web3 in general, so Web3 is all about like decentralization. So there's nothing like a single server that's sort of hosting like the Polkadot network. When I say Polkadot network, it is running across, all these nodes. So the point being, even if some of these nodes are like sort of shut down, it wouldn't affect the the blockchain itself. I mean, there are limits to how many of these nodes can shut down, but anyway. So the point being, like in Web3, everything is decentralized, or at least every project tries to decentralize itself. So Polkadot itself has like all these nodes that sort of keep the network operational, spread across like the world. Yeah, so the full functionality of Polkadot was launched sometime back last year, like in October. Like we had launch of like parachains functionality. So we had like parachain auctions, if you're following the space. So to become a parachain, you have to like bid and sort of win that particular slot, and then you become a parachain. So all of that started like last year, and right now we have over 20 parachains on Polkadot. So you can sort of check these individual projects. So all of these are blockchains in themselves. So basically, here, yeah, you could, I mean, I'll probably show it live like later on. But if you go to, parachain section in that particular Polkadot.js link, so you would see this, like every chain has, its own like block number right there. So all of those are trying to add blocks to their blockchain. And then they're, somehow using Polkadot to add blocks on top of their blockchain. So basically these parachains don't have any underlying consensus mechanism. So they rely on Polkadot to finalize like their blocks, and they keep adding blocks to their blockchains. As you can see, like the Polkadot has, so like Bitcoin has like miners, Polkadot has like validators, so validator nodes. So you see that some validators are assigned to each parachain out there. So more on this later, just giving you a glimpse of what the network is. So another unique thing about like Polkadot ecosystem, and many other ecosystems are considering this idea as well, is that we have a Canary network. So what's a Canary network? Like previously, people, when they were trying to like do some mining, like in some caves, so they used to take like some birds in there just to check like how the health of the miners would be sort of affected. So Kusama is that kind of so those birds were called canary birds. So Kusama is like the Canary network for Polkadot. So any sort of new feature that's going to be rolled out on Polkadot is first tested on Kusama. So again, so Kusama is just like Polkadot network. Again, you see the block production time is like 6 seconds. It has like more blocks than Polkadot because, so this Canary network started much earlier than the actual Polkadot network itself. So this is like an invaluable asset to Polkadot ecosystem because, even the parachains, like, the parachains that want to be on Polkadot, which is more of like enterprise level security and stability and performance offered, on Polkadot. So all of those projects that are trying to become parachains on Polkadot can first become parachains on Kusama. So basically, yeah, let's say you want to, so you've coded your program very well, your blockchain is running very well, you think everything is going according to the plan, but somewhere there's some kind of like vulnerability in terms of like code or in terms of like design flaw, because blockchains are essentially, like everything in Web3 is like incentive based. So whenever you have incentives, there are people who always want to take advantage of those incentives, right? So people just want to like game the system and take some kind of advantage when there is some value to extract from that network. So that kind of design flaws, code vulnerabilities, all of those can be filtered out by deploying on Kusama, where the network itself is not just a test network. It has like a real economic value. So the KSM token has like economic value. So you would see firsthand in like real world environment, like how your blockchain application is working. And when you're confident about like its results, you're going to move it to Polkadot, which is much more, high stakes environment. So every parachain here most likely has, a counterpart on Polkadot, but there are few projects that are okay with the levels of security offered by Kusama. So they just want to stay on Kusama, which is okay. But again, yeah. So depending upon your blockchain use case, you're going to pick like one and then move to the other. So the features I'd like to highlight in Polkadot are these. One, I've talked about this earlier. So Polkadot connects all these blockchain networks together. Shortly, like we're going to see how Polkadot actually achieves that. So handles heavy traffic at scale. So one thing you have to understand is most of the blockchain applications out there, so they don't need like a lot of, so the transactions per second argument is not very valid for multiple blockchain applications. So for instance, like Bitcoin has like what, it confirms transactions like every, so every 12 minutes, and then if you really want to be sure that your transaction is in the blockchain, you have to wait up to like 2 hours or so. So blockchain applications in themselves, like, so require a certain level of throughput, and Polkadot offers, much more than what most of the blockchain networks sort of lead. So the next thing is like security. So even this will be discussed in depth. Like how does like Polkadot secure these individual blockchains that have become parachains? What actually secures it? So in terms of like Bitcoin, it is, proof of work. So for those of you who are not familiar with proof of work or proof of stake, just know that it's like there are plenty of miners that are out there who are running Bitcoin nodes. Each of them buys like a lottery ticket to produce the next block. We don't know who's going to win it, right? So that sort of ensures that even if there is like some malicious actor with a lot of nodes, so they might not get a chance to create the next block. So that's how like Bitcoin provides security to the blockchain, and a lot of cryptography as well. I'm simplifying it like very, to a very low level here, but yeah. So in nominated proof of stake or proof of stake systems, so it's the people's funds at stake there. So if everything works according to the protocol, the funds are safe. In fact, they'll be rewarded. If something goes wrong, and then if you're acting out of pure malice, like you're just plain evil and then want to like destroy a lot of value on the network, then that to even do that, you have to have a lot of stake in the network, and that stake will be slashed. So basically you're literally losing the money for nothing. So proof of stake is like, having people's like monetary interests as like a security to secure the network. So more on this later. Yeah. So another feature, so if you plan on attending the next session, which is like Substrate 101, so I'll show you how to create like custom blockchains. So Polkadot comes with like this blockchain building framework called Substrate. It allows you to create like blockchains for your own use case. Name any use case that you want to put on like blockchain. Substrate has the capability to right off the like shelf. Like there are multiple libraries that you can directly like import, or you can like create your own libraries and add to the repository. Yeah. So the other interesting feature about Polkadot, so if you follow Polkadot space, we do have like functioning governance. So a lot of things on the network, every change to the network, it goes through like governance. Like people have to literally vote on-chain like proposals, and then only then like changes sort of happen on the network. And also there is like a treasury. So Polkadot has like a treasury, which is sort of used for funding like events like these, like, hackathons, conferences. So we have like a functioning treasury that actually, takes care of the blockchain network itself. Because if you think of it, a blockchain dies when, when there is nobody adding another block on top of it, because it's a decentralized network. So if there is no interest for people to sort of add blocks on top of the blockchain dies. So you have to incentivize people to actually keep the blockchain live, right? So the treasury is one of the mechanisms that sort of ensures that the Polkadot blockchain protects itself, and sort of keeps adding the blocks in there. So I have a question in there. So let me see if I can answer that quickly. So if people with a lot of stake would like to change the mechanism, something. Yes, so I have this later on. So I'm going to discuss that. It's a very valid question. So Bitcoin is prone to the 51% attacks as well. So there are few quantifiers that define like, how much stake would you need to have like maximum influence on Polkadot. So I'll talk about that as well. And this is my favorite feature. So we have self upgrades or forkless upgrades, as we call it. So this enables like, Polkadot to upgrade itself. That is my favorite feature of all. And then I'll explain that at the end of today's talk. So let's go to next slide. All right. Yeah, so just want to highlight like blockchains in general, they're suited to do one thing very well, like Bitcoin network. All it does is keeps track of balances and balance transfers, etc. It's basically a ledger, a distributed decentralized ledger, and that is all it does. So it doesn't do anything more. And if you try to do something more out of like Bitcoin blockchain, so you'll hit a lot of like roadblocks. Whereas like Ethereum in general, it's designed to be like a general purpose like blockchain where you can deploy application of your own. But again, like Ethereum has its own like rules as to how all those, so it's basically a smart contract blockchain. So how do those applications like work? So all of that is defined in Ethereum's like logic. But again, yeah, so the point being that blockchain can be used to do many things. Like I mentioned earlier, every parachain on Polkadot could either choose to be like, this very application specific blockchain or like a generic blockchain. So even the parachains that are already onboarded now, so the distribution is like half and half. Like, some do only some application and some are meant to do like a lot. So these custom blockchains, so they can have like numerous use cases. So for instance, we have like an Internet of Things like parachain. We have like identity services out there. We have like data storage, and there is even like distributed cloud computing. Like you could actually have, you could actually use your computer to serve other people's like computations with privacy in mind. So we have like different use cases and parachains that are being explored on top of like Polkadot network. So you as a developer, like if you're trying to build a new blockchain for yourself, so the key things that you'd be looking for are like performance. You'd want your blockchain to perform well, the applications on top of your blockchain to perform well. You want all of those transactions or your blocks to be secure, right? So the whole use case of blockchain is that once a transaction goes in there, nobody will be able to mess around with it. Nobody will be able to like spoof it. There's a lot of cryptography in action, and all of that has to be secured. So in a way that things can't be reverted, etc., and so on and so forth. So you want whatever is happening on the network should be faithfully be captured in the blocks. And at the same time, you also would want like some kind of sovereignty. You do not want to like give up the control of your blockchain to some other entity, or to the flaws of a different entity. So you don't want to have that dependency. You are in charge of your blockchain, or at least your community is in charge of your blockchain. So some kind of sovereignty is needed, and that's where so these are the things that you would consider, and then you look at like solutions that would offer all of this for you. So a couple of things, like if you try to start your own blockchain, then you'll have some kind of overhead. Like if you're trying to build a blockchain from scratch, you have to build the networking layer. You have to come up with a consensus, or sort of use an existing consensus and the blockchain like logic as well. And if you do it on your own, you're again like an isolated blockchain. So as you can see, with so many bridges and so much of interconnection between blockchains out there, there's a lot of demand for blockchains talking to each other. So if you choose to like do like your own thing, then you'll probably be isolated, and you're not connected to the services that are out there, which are blockchain based. And again, like security, like no matter which consensus security scheme you choose, you're competing against like all the blockchain networks out there, because people have limited resources, so they would choose to run one node or the other node, or multiple nodes or whatever. So the resources are being actually spread across like different blockchains. So yeah, so just to give you an idea like how difficult it is to bootstrap like your own blockchain in the current setting. So looking at all these like shortcomings, so basically Polkadot was designed from ground up, keeping all of these in mind. It took about like how many, like 5 years for the whole idea to come to fruition. Polkadot is like the first fully sharded like production grade blockchain that is out there, which is actually running these blockchain shards on its layer 0 relay chain. So yeah, so the idea was conceived like in 2016 by Gavin Wood, who is like Ethereum co-founder. So he was also CTO of Ethereum, who like built like EVM. So he knows the in and outs of like how Ethereum works. And so a lot of design considerations of Polkadot were meant to like put it like as a layer 0 solution, not like a layer 1 solution like Ethereum, which has it like its own rules of doing things. So Polkadot sort of enables blockchains to have their own rules. So the idea was to create like a generic, abstract layer 0 protocol that enables like chains like Ethereum to run on top of it. So that was the path. And then I already mentioned I would talk about interoperability. So this is like a hot topic in the ecosystems in general across like all the Web3 ecosystems. So the concept of like bridges has come to a lot of scrutiny over the last year. So I'll talk about it in a bit, but as you can see, Polkadot needs to talk to other blockchain networks as well. So there are two things here. One is these parachains talking to each other. So that's one thing, and then all of these parachains on Polkadot talking to like Bitcoin blockchain or like Ethereum blockchain, or even like Kusama. Again, like Kusama is like its own like blockchain network. Like I mentioned earlier, it's an independent blockchain. It has its own governance. It has its own like token and tokenomics, or so on and so forth. So even like talking between Polkadot and Kusama has to be done through what is called a bridge. So bridges are flawed in general. Like you've seen that over like every 2 weeks you hear about a hack that is happening on bridges, right? So some kind of vulnerability, some kinds of like design flaw, and so on and so forth. So basically, the more value you have on the bridge, the more susceptible it is for attacks. All the things that I put here have their own reasons for the failure. But the common theme across this is because there is a lack of like standardization, and fully audited code. We have this issue that a lot of these bridges are being hacked. So the the solution from ground up, like what Polkadot is doing, is called like cross consensus message format, which is called XCM. So I have a bunch of links up there, so feel free to like click on them and dig deeper. So XCM, which stands for like cross consensus message format, is trying to be like that standard, audited set of like instructions and code, which sort of assist like these blockchains to talk to each other, not as a form of like smart contract, but at the layer 0 level, right? So it's burnt into the protocol itself, and it is audited, and nobody can actually hack or take advantage of it in terms of like, at least the code. So that is the solution that Polkadot the design decision was taken like much earlier to have this interoperability protocol within Polkadot ecosystem, like one parachain talking to the other. So it does through XCM as well, and then it's expanded so that we have these trustless protocols, bridges that are under development for um, external blockchains like Bitcoin and Ethereum and Kusama. So all of these will be like trustlessly administered without like a third party controlling like the bridge. But anyway, so XCM serves that purpose for you. And then yeah, like I mentioned, one important thing is when you're rolling this out at this particular scale, so you have to get your like code sort of audited. So we have like multiple audits on XCM as well. And the code is like open source, it's public. And so the idea is that nobody should be able to like take advantage or hack the underlying protocol. So you don't hear about hacks in like internet protocol in general, because everything is transparent. Everybody knows what the protocol does and the source code. So this tries to be that kind of like standard for blockchain interoperability within Polkadot ecosystem, and hopefully if it gets adopted, like overall Web3. So other ecosystems doing similar work are Cosmos. So Cosmos does actually it sort of matches with the IBC, right? So inter-blockchain protocol. So IBC is what like Cosmos has. So they have like their own design choices on how like blockchains talk to each other. But yeah, so XCM and IBC are the ones in the ecosystem that are actually putting thought into making this work. So the idea for XCM would be this: like we would want secure communication for like a multi-chain world. So there's no denying that there is demand for multi-chain applications. So people want to leverage. So Web3 is all about leveraging different blockchain networks out there. Not everybody wants to reinvent wheel. If somebody is doing something like very well, you'd want to use their service, and then you build something on top of it. Like the whole talk of composability is what is highlighted right here. And XCM is sort of targeted to make it a reality. Okay, so let's see how we are doing with time. Yeah, we have about half hour. Yeah, so I'm going to briefly show you a trailer for what's coming in the Substrate workshop. I think it's on August 9th. So if you're a developer and then you'd like to see like what features Substrate offers, that workshop is for you. So I'm going to have like a brief hands-on activity here if you're interested. So basically Substrate, again, we give this to like general audience. Like you can think of like a DJ at a party where, depending on the song, you sort of adjust like parameters. So Substrate blockchain building frameworks sort of gives you that kind of flexibility. So depending upon your use case, you're free to change, most of the parameters in there for your blockchain application. So the protocol development itself, it's, so Web3 Foundation, which is where I'm from, this is where like the researchers are, like, we are the ones who came up with like the consensus mechanism for Polkadot, the nominated proof of staking, for which like there was a question I'll answer shortly. And then like anything to do with like Polkadot research, cryptography. So all of this comes from Web3 Foundation. And Parity, which is based in like Berlin. So they have like over like I think 150 developers or so who are dedicated to developing like blockchains, the core aspects of like blockchain. And Parity is not like a new organization, so they have been instrumental. Like I said, Gavin Wood is like founder of Parity as well. They were called like ETH Core like back then, and then they got renamed to Parity. The point being, they have like blockchain clients for Ethereum, Bitcoin. So they have extensive like blockchain building development experience, and then they ventured into building like Polkadot. So when building Polkadot, they felt like a lot of what they were doing can be reused, by others as well. So that's why they made many aspects of like Polkadot like open source. I mean, everything about Polkadot is open source, but in a different repository on its own, and they named it like Substrate. So everything to do with like consensus, networking, all that boilerplate is right here. And if you actually look at like Substrate, it's actually modular, flexible, and extensible, meaning many so all the libraries in there, they're very modular. They're kind of like Lego blocks that you can put together. So they're flexible, meaning like you can go to any of these module and sort of change like the parameters in it. So it offers that flexibility. And the other thing is it's extensible, meaning you can add more modules to the framework. If you see something is missing, you add that module on your own. So the point being, you're using battle tested like libraries right from day one in your blockchain development cycle. So if you look at the Polkadot code on GitHub repo, so you see a lot of overlap with Substrate, and Substrate has much more than Polkadot. For instance, being a layer 0 blockchain, Polkadot doesn't need like smart contracts. So basically, smart contracts are something for layer 1 blockchains, which are going to be like parachains. So they have like smart contracts, and Substrate, sort of has those libraries as well. So if you're building a parachain on top of Polkadot, you have a range of like libraries to choose from, build your custom blockchain, and then deploy it on top of Polkadot. So by design, Polkadot protocol has to be very simple. All it has to do is enable block validation through like, validation mechanism, as well as let these parachains like talk to each other. So that should only be the focus of Polkadot, being like an underlying layer 0 blockchain. So if you really want to get started like today, and you have like a use case in mind, name it like DeFi, NFTs, smart contracts, file storage, social network, etc. So we have like a wide range of like projects that are being built using like Substrate. So one quick way would be to see like which of these projects have like a public repository out there. Lot of like, so Web3 Foundation also gives research grants. So if you get a research grant from Web3 Foundation, you have to put your code like online, and you have to make it like open. So there are plenty of over like 400 projects that have grants from Web3 Foundation, which eventually became like parachains. So at least you have like the starter code to begin with in all these like areas. So that would be the way to go if you're interested in developing a blockchain application with these use cases. And the way like runtime. So runtime is like the blockchain's brains, right? So all the logic that you include in runtime, so that is how like the blocks are going to be produced. That is how the transactions are going to be processed. So the way like Substrate works is, so let's say I want a blockchain with like accounts with like balances features in them. So I would just drag and drop like balances palette, and then so you have that feature right from the beginning. Now, so Substrate is coded in Rust. So that's one barrier. Like Rust is not usually taught in the universities. So we are making like efforts and collaborations to create like more Rust related like programs at universities, but that's going to take time. Yeah, so there's some learning curve there. And then Substrate has its own like design. Like knowing Rust is one thing, and then understanding like Substrate, the way things are organized in Substrate, it requires some learning curve as well. But once you're familiar with both of these, then blockchain development it looks just like this. And then I'll try my best on the August 9th session to show you, like, how this is done, and what are required to sort of write your own palettes like this one on Substrate. Yeah, but the point being, like, you're free to drag and drop like palettes, what we call them. These palettes are libraries, so which have like a specific modular functionality. So at the core, like the Polkadot, or Substrate nodes, so their anatomy looks like this. So right at the below, you have like networking protocols. So we use lib peer-to-peer protocol. So this was developed by the people who developed IPFS. So IPFS is a standard for decentralized storage. So this is not developed by Parity or Web3 Foundation. So we reuse like a open library, and then so everything in runtime, like the whole logic itself. So all of that compiles to WASM. So WASM is WebAssembly. So that's one more thing I would ask you to like check out. So WebAssembly is this technology that's going to take blockchain applications to the next level, because WebAssembly sort of supports execution in environments like browsers. Like you can just execute clients like blockchain nodes in a browser as well. So WebAssembly actually facilitates that. And so Grandpa is something that Web3 Foundation researchers have come up with. So that's the consensus mechanism that is used in Polkadot, which you can use when you're trying to build your own blockchain network. So there is a blockchain template node. I'm going to quickly ask you to, so for those of you who already have a GitHub account, you can click on this playground.substrate.dev. I'm going to quickly show, we'll be using this in the workshop session on August 9th, but again, I'm going to show you like what this looks like. So I have Substrate Playground right here. So it basically opens the Substrate template node for you. And then, clearly I started this before this workshop session. So right from the beginning, it compiles, and then you have like a blockchain in action. So this is on the command line, but if you want to see that thing in action through, I mentioned already to you, like Polkadot.js is used by developers. So it makes like blockchain development a lot easier. So you can actually like visualize what's happening in this blockchain network that you just built and executed right away on like Polkadot.js. If it sort of loads, let me see. The Zoom controls are. All right, so whatever you're seeing at the command prompt, in the Substrate Playground, you see them in a better way on this UI. So there are 482 blocks already created in this blockchain. So you can also see all the commands that you can actually give to your blockchain. So right now, so I talked about palettes, right? So by default, there are like balances, there's a consensus, and then there are a bunch of other sort of palettes in that Substrate template node to begin with. So it comes with like some default accounts, with like some balance already. So overall, like Substrate template node, which you can access here, or you can also download and compile on your own machine. So that gives you a huge boost in terms of like blockchain development, because you have a fully functional like blockchain right from the start, and then you can add features in here. So for instance, so here is where like palettes, like the things, the runtime, the brains of the blockchain. So you can actually add your own palettes here if you want. You could also like import like existing palettes into your blockchain. So you do that. So if you're familiar with like Rust, So let's go to like this cargo file. Yeah, so in here, you just add like dependencies, and then you just import like the respective palette in here. So these are the libraries that are already mature. So they're available for you out there. So you can just add them to your runtime this way, and you do something more. Again, just giving you a flavor of blockchain development using Substrate to be covered in the workshop, dedicated workshop. But yes, so this is how it is. So feel free to like play around with it. And if you intend to attend the next workshop, like, play around and then come to the workshop prepared. So that I'm gonna. Yeah, so that's the playground link. Feel free to like play around with it. And yeah, so we're reaching kind of the end of the presentation. So I'm going to talk about like the governance that Polkadot has, and like the nominated proof of staking, and finally the self upgrades. So a lot of blockchains out there, they don't have like governance in general. So for example, like Bitcoin, there's no governance. So there's no like a body that decides what the future of the network is. So it's ultimately the miners or the ones who are creating the blockchain network. So whatever software they use, the majority is going to define like a chain that is sort of the standard chain. So if you heard of it, like Bitcoin actually forked, like there was a hard fork in Bitcoin when people didn't agree to the network upgrade. The ones who didn't agree added a blockchain on their own, and the ones who agreed, like they had like another blockchain, so which is Bitcoin Cash and like Bitcoin or whatever. So there are issues like this, right? So you don't want like hard forks sort of affecting your community, splitting like the whole ecosystem. So the point being, you would want the governance to be on top of the chain itself. Like you don't want to host like conferences or be on Twitter and say, okay, so this is the future of the blockchain, and make people sort of like download that software and run it. So you would want to have that kind of governance on chain itself, and that's going to decide the future of the chain. So Polkadot falls here. So we have a community that proposes the changes on chain, on the blockchain, and then that change will be sent for like a vote. So we have a referendum mechanism, which is like a direct democracy. So you're going to like vote on those proposals, and then so the one that passes is going to make it through, and the upgrade sort of happens. And Polkadot governance is like constantly in flux. So we are trying to improve the governance. So if you're following the space, there's also a push for the next version of governance. So that sort of eliminates the council. So council is so there are like 13 council members on Polkadot, who sort of hold few powers to in terms of like governance. They can do something more. So they're sort of like delegates of a lot of voting power. So it's going to like get rid of this council and the power of like technical committee, etc. But again, like if you are interested in governance, follow those updates. But Polkadot does have like one of the impressive governance systems in blockchain ecosystem. If you want to check out like live on what's going on in terms of governance, again, Polkadot.js UI, it provides like the governance tab. So you can check like what proposals are being made on chain. So we have a treasury as well. We have bounties. So bounties are like, so you can have efforts like anti-scam as a bounty. A pot of funds are reserved for a specific use case, and then you're going to give it out through the treasury, through a committee or whatever. So a lot of interesting things happening in the governance tab. So there is also like a public governance channel where you can see the discussions, how people like propose something, the discussion around those proposals, and so on and so forth. So feel free to follow that if you're interested. And the interesting thing about this is the governance, it's just not just a proposal. It has to be accompanied with the code as well. So meaning if you're trying to change something in the network, you don't simply say that you're going to change it. So you'll also provide the code that actually changes it. Okay, so the proposal comes with like the actual code that makes the changes. People who are voting for it, they're going to ensure whatever they're proposing is the one in the code. And only then it's sort of like after approval that code goes into the network and becomes like the status quo. Yeah, so let's see. Yeah, running short of time. Okay, so in terms of security, so the 51% attack that we touched upon earlier. So let's see what happens in Polkadot and how things go. So if you look at what's called like Nakamoto coefficient for Polkadot, it is in the scale of like 100, whereas other networks have very, very smaller numbers there, because to actually compromise Polkadot network, so Polkadot network right now has like about 300 validators who sort of add blocks to the blockchain, like in each day, each era. So you have to compromise like 100 nodes to be able to have a say in the network. So these 300 nodes, or in the future like 1,000 nodes, are going to be elected by what's called a proportionally justified representation. So I just want to show a few cases just to give you an intuition of what this means. So this is not a proportionally justified representation, right? So two nominators with like dots or tokens with 10 and 18, significantly larger than other people, want this particular node to be elected into the active set. So not electing this node is not what this algorithm should do, but it could do this or this. So here, even though this guy with like 18 tokens is selecting B, they're also selecting like A and C. Okay, so and B is only selected by this particular node. So this can be kicked out. That's totally fine. And then here, the validator E is being picked by someone with like very, very low stake, and they can be kicked out as well. So these two are okay. So the point being, you want to maximize the total stake on the network. So why do you stake? So when you say stake, you're putting something at risk. So you're ready to lose your funds if somebody does not contribute to the network as expected. So the protocol itself has to maximize the total stake on the network, and this takes care of that. And between these two, again, like nominated proof of stake has to select the highest security level. So that can be seen here. So in this distribution, like you can distribute the stake across these validators. And so this value to get like a validator into the active set, so it shouldn't be so small. Okay, so you distribute the stake in such a way that the lowest staked validator who can enter the active set, so that value is much higher. So Polkadot has this sophisticated nominated proof of stake system. It actually runs off chain. So the election solution is sort of determined. It's like a graph between nominators and validators. And it tries to maximize the overall stake on the network. And it also tries to maximize the stake of the lowest staked validator. So these 300 validators get elected. And this is what makes like, someone with a lot of DOT tokens, even if they try hard and only like, choose a single validator with their stake, only that validator is going to make it, or they'll have to like spread it across. And the whole proportionally justified representation algorithm for NPOS sort of makes it difficult. So other proof of stake mechanisms use weighted stake. So let's say you are like a rich person, and then a whale in terms of like Web3 terminology. So the validator you elect, has a say in the network based on the number of tokens that are backing that particular validator. So it's not the case in Polkadot. So all of these validators will have like equal privileges when creating blocks or during the block production. Yeah, so that's nominated proof of stake for you. A brief overview of Polkadot architecture. So you have validators. So these are the ones that are going to be elected by the whole Polkadot network. So right now there's about like, I think 50 or 55% of dots that are staked. That's like 500 million dot. And then, so that corresponds to some monetary value, right? So that much money is at stake for the network to work as expected. And you get rewarded for staking. And if you do something bad, so you're going to be slashed, and that's not in the best interest of someone who's holding a lot of stake in the network. So all of these validators are elected through nominated proof of staking, and these are like randomly assigned to these individual parachains. So they don't know ahead of time, like which parachain they're going to like sort of assist in block production. So that's what like secures the whole network. So the nodes that like I said, a parachain is a blockchain network as well. So it runs its own nodes, and they are called collators. So the job of these collators is to create like a block that can be validated by Polkadot. So the point being, so basically all these validators are assigned to a parachain. So this parachain has like a collator. They create a block, they send it to these validators, and they validate that block, and then sort of say, everything works as expected, and include it in the certificate of it in the relay chain. So if you're interested in like the path of that particular parachain block, I would request you to check like this article. Unfortunately, we're running short of the time, so I'm going to have to accelerate here. Yeah, so the whole point being, like the parachain block, the entire block itself need not be sent to the Polkadot validator. So for instance, someone sends a balance to someone else and something else changes in the parachain state, only those changes need to be sent. Everything else is the same. So if you're familiar with like hashing, so the other hashes are going to remain the same, only the changes need to be propagated, and that particular changes are going to be validated by the Polkadot validators. And if everything sort of works well, the whole block is not stored on the relay chain, so it sort of beats the purpose. Only a certificate is stored there saying that that particular parachain block is final, and the parachain can keep adding blocks on top of the finalized block. Coming back to the favorite feature, if you're a blockchain in Polkadot ecosystem, you can start like this and then eventually upgrade your blockchain this way. The way it's done, like for Polkadot and its parachains, is like this. So conventionally, if a blockchain has to be upgraded with a new feature, it can have forks like these. So this problem is sort of eliminated in Polkadot because the core logic for state transition, so that logic is part of the block as well. So like I mentioned, any sort of upgrade is sort of coded into the blockchain, and it's part of the blockchain through on-chain proposal. So let's say at this block, the vote passes through on-chain governance and the upgrade happens. The next block will be created automatically based on that upgraded code. So the validators need not sort of download a new software and then start running it. Just the block production mechanism itself does the automatic upgrade of that feature, and the next block gets seamlessly added to the blockchain. So there's no concept of forking here. And of course, there'll be split in the community, but that split is going to have a result, and it doesn't affect the whole network. It's not going to split the whole network. People are going to fight it out in the on-chain proposal here, and the winning vote is going to be enacted as the upgrade, and the blockchain sort of upgrades itself. So the network resources itself are going to be intact, and and there won't be any sort of forking in the blockchain. To summarize, yeah, so I'm going to take 2 more minutes and then I'm open for questions. So for every need that is out there, so we have come up with like some solution. For instance, like for composability, for ability to trustlessly add services in your blockchain application. So we created like cross-chain messaging format. For security, we chose like nominated proof of staking, our own spin to the proof of stake, consensus. So we have like on-chain treasury to fund like efforts, high throughput in terms of like total number of transactions. So we have heterogeneous sharding. So a parachain can run like different blockchains in parallel as well if they plan to like win a slot, multiple slots. So that's going to increase their throughput and so on and so forth. So there are like over 175 projects that have expressed interest to become like parachains on Polkadot, and also like each parachain itself can host a lot of other applications. So think of Ethereum and all the applications on it. So that's like one parachain in Polkadot. So the options are limitless. So we have given grants to numerous like projects with so many like use cases, and yeah. So with that, we conclude the presentation today, and then now I'm open for questions.
All right. Thank you, Radhakrishna, for the insightful session. I'm sure our attendees have had a better and in-depth understanding of the Polkadot framework and the parachains. Next up, we have a few questions from our audience and from our community. So I will go ahead with some of our community questions for now. So one of the members is asking if Polkadot services rely on AWS or services like that, cloud services like AWS and Azure.
Yeah, so that's one big problem that is plaguing like blockchain and Web3 ecosystem right now, because we claim to be decentralized, but again, like if you're using centralized services like AWS or Google Cloud or something else, if they're shut down, then the network shuts down, right? So we are tackling this problem, in a different way. So we have what's called 1,000 validator program. So I can actually share that link in a bit. So 1,000 validator program is a program set up by Web3 Foundation to help like or support individual like so individual like validators to get onboarded as like validators for the network. Now the point system in the 1,000 validator program. So one particular aspect reduces your points. So if a lot of nodes are running on the same service provider, so you get like very less points there. So you're incentivized to find a solution where you're not running the nodes at the same location. So that's one efforts that we do, and we do have that thing in our long-term strategy as well. We want to decentralize the network as much as possible. Even like burn that into the protocol itself, so that the nodes that are very proximate running in the same location, so their incentives would be different or lesser than the nodes that are running elsewhere. Hope that answers the question.
All right, thank you. Another question is, do you see Web 3.0 replacing Web 2.0 completely in the coming decade at the pace it's moving right now?
I mean, I've talked to a lot of like experts. So personally, I have my PhD in computer science and in computer vision, artificial intelligence. So I've had an option to see like the Web 2 thing with a lot of my friends as well, and a lot of Web 2 companies. And I see a lot of people in Web 3 as well for the past 1 year. So the point is, it's not a replacement. It's what we call so it's just like redesigning the internet as it is. So right now, users don't have a lot of rights on their data. So they're giving away a lot of their freedom, putting it in these centralized servers, centralized services for doing anything, for the sake of convenience. So Web3 is going to give that control back to the users, and the Web2 services are also going to be there. So it's that aspect where, so we don't have to give away a lot of sovereignty to centralized entities. We would want to sort of, change that particular aspect with the use of like blockchain technology, and everything that we have can coexist with like what Web3 is doing. So it's almost like sign in with Google, sign in with Facebook, sign in with Web3. So
Right.
where you have like new paradigm of interacting with services we already have on internet.
Right. Makes sense. So one of the users has a query. I know basics of C++ and Python. Is that sufficient knowledge for me to start learning Rust and Substrate and other?
Absolutely. So Rust. So anybody who picked up on Rust with like C or C++ background, so they all appreciate like the the elegance of the language itself, like how it handles like all the things that C and C++ handle in an elegant way. So the Rust textbook that is online, so that has been the source for me as well. So it gives you a very good, it's like an open textbook. So you can start that and then get a hang of like what Rust does. And Rust is being like adopted across a lot of Web2 companies as well, not just like Web3. So that's a good skill to have in these days.
All right. So we are also live on YouTube right now. So some of the questions are coming in from our audience on YouTube. So can these workshops help me to start freelancing for Polkadot? Is one of the questions. Yeah.
Yeah. So again, like freelancing for Polkadot is like the scope is so big, like Polkadot ecosystem in general. So we have like core protocol developers, like Polkadot protocol developers, and the para chains, which are like layer 1 blockchains and applications on top of those. So it's very wide. I would say if you have any sort of like front end experience, I think this is the best time to be involved in Polkadot, because so far the focus has been on improving like the backend. Like we wanted the protocol to be stable and functioning to develop like all these applications. So if you're like a front end developer, and if you'd like to freelance for any of these parachains, or even like Polkadot, like building wallets and stuff, or interactions, block scanners. So there are numerous like this middleware that you could develop, or like front end stuff that you can develop, like JavaScript. Experience will be of a lot of help for the ecosystem. And check out like the treasury proposals on like Polkadot. You'll see like multiple freelancers or companies that are sort of putting it out there and then getting funding. That's also something you can monitor.
All right. So one more question we have is the demand of blockchain developers all in all in the developer community. Is this going? Do you see it increasing in the coming days?
Yes, absolutely. So you can check like Dot jobs or KSM jobs, or Web3 jobs anywhere. So you see plenty of like roles starting that are not necessarily like blockchain developers, but anything to do with like blockchain technology, right? So like I just mentioned, like front end engineer for like a blockchain application. So the jobs are only like increasing. There's a lot of demand. There's a lot of investment, I would say, in the whole new way of internet being like reorganized. So there's still a lot of interest, and yeah, so we don't see that going down any time sooner.
Right. Okay. So I think we'll conclude here for now. So, yeah, I think that will be all the questions for now.
Yeah, I think I'll answer one question by Prajwal in the chat. So how is Polkadot connected to other layer 1 blockchain? Like if you're talking about like Ethereum or Bitcoin. So for Bitcoin, we have like Interlay, which is like a parachain that acts as a bridge to Bitcoin. And so that's supposed to be a trustless bridge. So even for Ethereum, so Polkadot can understand like what's happening in Ethereum, but the Ethereum, so doesn't put that effort to understand like Polkadot. So but that can actually be done, and it's in development as well. So that's so that protocol is that bridge protocol will be live like soon. Or
All right. Thank you. So, guys, thank you so much for tuning in. I would like to thank everyone for coming out today and taking part in our workshop. It goes without saying that this workshop would not have been possible without Mr. Radhakrishna and the Polkadot team. So, thank you so much for this collaborative effort. We had a really interesting conversation with you, Mr. Radha, today, and you gave us a detailed look into how the blockchain projects are built on Polkadot. Um, so, we will be coming with more such workshops for you. So make sure you stay updated by following IBC Media on our social channels. Also, you can visit our website, ibc.media, to know more. Thank you, and I will catch up with you again. Stay tuned.